A lubricant is a substance introduced to reduce friction between surfaces in mutual contact, which ultimately reduces the heat generated when the surfaces move. It may also have the function of transmitting forces, transporting foreign particles, or heating or cooling the surfaces. The property of reducing friction is known as lubricity. In addition to industrial applications, lubricants are used for many other purposes. Other uses include cooking, biomedical applications on humans, ultrasound examination, medical examinations, and the use of personal lubricant for sexual purposes. Properties. A good lubricant generally possesses the following characteristics: high boiling point and low freezing point, high viscosity index, thermal stability, hydraulic stability, demulsibility, corrosion prevention, high resistance to oxidation. Formulation. Typically lubricants contain 90% base oil and less than 10% additives. Vegetable oils or synthetic liquids such as hydrogenated polyolefins, esters, silicones, fluorocarbons and many others are sometimes used as base oils. Additives deliver reduced friction and wear, increased viscosity, improved viscosity index, resistance to corrosion and oxidation, aging or contamination, etc. Non-liquid lubricants include grease, powders, PTFE tape used in plumbing, air cushion and others. Dry lubricants such as graphite, molybdenum disulfide and tungsten disulfide also offer lubrication at temperatures higher than liquid, and oil-based lubricants are able to operate. Limited interest has been shown in low-friction properties of compacted oxide glaze layers formed at several hundred degrees Celsius in metallic sliding systems. However, practical use is still many years away due to their physically unstable nature. Additives. A large number of additives are used to impart performance characteristics to the lubricants. The main families of additives are antioxidants, detergents, anti-wear, metal deactivators, corrosion inhibitors, rust inhibitors, friction modifiers, extreme pressure, anti-foaming agents, viscosity index improvers, demulsifying, emulsifying, stickiness improver, provide adhesive property towards tool surface, complexing agent. Note that many of the basic chemical compounds used as detergents serve the purpose of the first 7 items in the list as well. Usually it is not economically or technically feasible to use a single do-it-all additive compound. Oils for high-point gear lubrication will contain high content of EP additives. Grease lubricants may contain large amount of solid particle friction modifiers, such as graphite, molybdenum sulfide. Types of lubricants. In 1999, an estimated 37,300,000 tons of lubricants were consumed worldwide. Automotive applications dominate, but other industrial, marine, and metalworking applications are also big consumers of lubricants. Although air and other gas-based lubricants are known, liquid and solid lubricants dominate the market, especially the former. Lubricants are generally composed of a majority of base oil plus a variety of additives to impart desirable characteristics. Although generally lubricants are based on one type of base oil, mixtures of the base oils also are used to meet performance requirements. Base oil groups. Mineral oil term is used to encompass lubricating base oil derived from crude oil. The American Petroleum Institute designates several types of lubricant base oil. Group 1 saturates less than 90% N, or sulfur greater than 0.03%, and Society of Automotive Engineers viscosity index of 80 to 120. Manufactured by solvent extraction, solvent or catalytic dewaxing, and hydro-finishing processes. Common Group 1 base oil are 150SN, 500SN, and 150BS. Group 2 saturates greater than 90% and sulfur less than 0.03%, and SAE viscosity index of 80 to 120. Manufactured by hydro cracking and solvent or catalytic dewaxing processes. Group 2 base oil has superior antioxidation properties since virtually all hydrocarbon molecules are saturated. It has water-white color. Group 3 saturates greater than 90%, sulfur less than 0.03%, and SAE viscosity index over 120. Manufactured by special processes such as isohydromerization. Can be manufactured from base oil or slax wax from dewaxing process. Group 4 polyalpha olefins. Group 5 all others not included above such as naphthenics, PAG, esters. The lubricant industry commonly extends this group terminology to include Group 1 plus with a viscosity index of 103 to 108. Group 2 plus with a viscosity index of 113 to 119. Group 3 plus with a viscosity index of at least 140. Can also be classified into 3 categories depending on the prevailing compositions: paraffinic, naphthenic, aromatic. Lubricants for internal combustion engines contain additives to reduce oxidation and improve lubrication. The main constituent of such lubricant product is called the base oil, base stock. While it is advantageous to have a high-grade base oil in a lubricant, proper selection of the lubricant additives is equally as important. Thus, some poorly selected formulation of POW lubricant may not last as long as more expensive formulation of Group 3 plus lubricant. Biolubricants made from vegetable oils and other renewable sources. These are primarily triglyceride esters derived from plants and animals. For lubricant base oil use, the vegetable-derived materials are preferred. Common ones include high oleic canola oil, castor oil, palm oil, sunflower seed oil and rapeseed oil from vegetable, and tall oil from tree sources. Many vegetable oils are often hydrolyzed to yield the acids which are subsequently combined selectively to form specialist synthetic esters. Other naturally derived lubricants include lanolin. Whale oil was a historically important lubricant, with some uses up to the latter part of the 20th century as a friction modifier additive for automatic transmission fluid. In 2008, the biolubricant market was around 1% of UK lubricant sales in a total lubricant market of 840,000 tons year. Lanolin is a natural water repellent derived from sheep wool grease, and is an alternative to the more common petrochemical-based lubricants. This lubricant is also a corrosion inhibitor, protecting against rust, salts, and acids. Water can also be used on its own, or as a major component in combination with one of the other base oils, commonly used in engineering processes, such as milling and lathe turning. Synthetic oils, polyalpha olefin, synthetic esters, polyalkylene glycols, phosphate esters, alkylated naphthalines, silicate esters, ionic fluids, multiply alkylated cyclopentanes, solid lubricants PTFE. Polytetrafluoroethylene is typically used as a coating layer on, for example, cooking utensils to provide a non-stick surface. Its usable temperature range up to 350 degrees Celsius and chemical inertness make it a useful additive in special greases. Under extreme pressures, PTFE powder or solids is of little value as it is soft and flows away from the area of contact. Ceramic or metal or alloy lubricants must be used then. Teflon Registered Sign is a brand of PTFE owned by DuPont Co. Inorganic solids. Graphite, hexagonal boron nitride, molybdenum disulfide and tungsten disulfide are examples of materials that can be used as solid lubricants, often to very high temperature. The use of some such materials is sometimes restricted by their poor resistance to oxidation. Metal alloys, composites and pure metals can be used as grease additives or the sole constituents of sliding surfaces and bearings. cadmium and gold are used for plating surfaces, which gives them good corrosion resistance and sliding properties. Lead, tin, zinc alloys and various bronze alloys are used as sliding bearings, or their powder can be used to lubricate sliding surfaces alone. Aqueous lubrication. Aqueous lubrication is of interest in a number of technological applications. Strongly hydrated brush polymers such as PEG can act as lubricants at liquid-solid interfaces by continuous rapid exchange of bound water with other free water molecules. These polymer films keep the surfaces separated while maintaining a high fluidity at the brush-brush interface at high compressions, thus leading to a very low coefficient of friction. Applications. Lubricants perform the following key functions: keep moving parts apart, reduce friction, transfer heat, carry away contaminants and debris, transmit power, protect against wear, prevent corrosion, seal for gases, stop the risk of smoke and fire of objects, prevent rust. One of the single largest applications for lubricants, in the form of motor oil, is protecting the internal combustion engines in motor vehicles and powered equipment. Lubricants such as two-cycle oil are added to fuels like gasoline, which has low lubricity. Sulfur impurities in fuels also provide some lubrication properties, which has to be taken in account when switching to a low-sulfur diesel. Biodiesel is a popular diesel fuel additive providing additional lubricity. Another approach to reducing friction and wear is to use bearings such as ball bearings, roller bearings or air bearings, which in turn require internal lubrication themselves, or to use sound, in the case of acoustic lubrication. Keep moving parts apart. Lubricants are typically used to separate moving parts in a system. This has the benefit of reducing friction and surface fatigue, together with reduced heat generation, operating noise and vibrations. Lubricants achieve this in several ways. The most common is by forming a physical barrier, i.e., a thin layer of lubricant separates the moving parts. This is termed hydrodynamic lubrication. In cases of high surface pressures or temperatures, the fluid film is much thinner and some of the forces are transmitted between the surfaces through the lubricant. Reduce friction. Typically the lubricant-to-surface friction is much less than surface-to-surface friction in a system without any lubrication. Thus, use of a lubricant reduces the overall system friction. Reduced friction has the benefit of reducing heat generation and reduce formation of wear particles, as well as improved efficiency. Lubricants may contain additives known as friction modifiers that chemically bind to metal surfaces to reduce surface friction even when there is insufficient bulk lubricant present for hydrodynamic lubrication, e.g., protecting the valve train in a car engine at startup. Transfer heat. Both gas and liquid lubricants can transfer heat. However, liquid lubricants are much more effective on account of their high specific heat capacity. Typically, the liquid lubricant is constantly circulated to and from a killer part of the system, although lubricants may be used to warm as well as to cool when a regulated temperature is required. This circulating flow also determines the amount of heat that is carried away in any given unit of time. High-flow systems can carry away a lot of heat and have the additional benefit of reducing the thermal stress on the lubricant. Thus, lower-cost liquid lubricants may be used. The primary drawback is that high flows typically require larger sumps and bigger cooling units. A secondary drawback is that a high-flow system that relies on the flow rate to protect the lubricant from thermal stress is susceptible to catastrophic failure during sudden system shutdowns. An automotive oil-cooled turbocharger is a typical example. Turbochargers get red-hot during operation and the oil that is cooling them only survives as its residence time in the system is very short. If the system is shut down suddenly, the oil that is in the turbocharger immediately oxidizes and will clog the oil ways with deposits. Over time, these deposits can completely block the oil ways, reducing the cooling, with the result that the turbocharger experiences total failure, typically with seized bearings. Non-flowing lubricants such as greases and pastes are not effective at heat transfer, although they do contribute by reducing the generation of heat in the first place. Carry away contaminants and debris. Lubricant circulation systems have the benefit of carrying away internally generated debris and external contaminants that get introduced into the system to a filter where they can be removed. Lubricants for machines that regularly generate debris or contaminants such as automotive engines typically contain detergent and dispersant additives to assist in debris and contaminant transport to the filter and removal. Over time, the filter will get clogged and require cleaning or replacement. Hence the recommendation to change a car's oil filter at the same time as changing the oil. In closed systems such as gearboxes, the filter may be supplemented by a magnet to attract any iron fines that get created. It is apparent that in a circulatory system the oil will only be as clean as the filter can make it. Thus, it is unfortunate that there are no industry standards by which consumers can readily assess the filtering ability of various automotive filters. Poor filtration significantly reduces the life of the machine as well as making the system inefficient. Transmit power. Lubricants known as hydraulic fluid are used as the working fluid in hydrostatic power transmission. Hydraulic fluids comprise a large portion of all lubricants produced in the world. The automatic transmission's torque converter is another important application for power transmission with lubricants. Protect against wear. Lubricants prevent wear by keeping the moving parts apart. Lubricants may also contain anti-wear or extreme pressure additives to boost their performance against wear and fatigue. Prevent corrosion. Good quality lubricants are typically formulated with additives that form chemical bonds with surfaces, or exclude moisture, to prevent corrosion and rust. It reduces corrosion between two metallic surfaces and avoids contact between these surfaces to avoid immersed corrosion. Seal for gases. Lubricants will occupy the clearance between moving parts through the capillary force, thus sealing the clearance. This effect can be used to seal pistons and shafts. Application by fluid types: automotive engine oils, petrol engine oils, diesel engine oils, automatic transmission fluid, gearbox fluids, brake fluids, hydraulic fluids. Tractor: universal tractor transmission oil, UTTO, super tractor oil. Universal STOU includes engine, other motors, two-stroke engine oils. Sexual personal lubricant, industrial hydraulic oils, air compressor oils, food-grade lubricants, gas compressor oils, gear oils, bearing and circulating system oils, refrigerator, compressor oils, steam and gas turbine oils, aviation gas turbine engine oils, piston engine oils, marine crosshead cylinder oils, crosshead crankcase oils, trunk piston engine oils, stern tube lubricants. Horological. Other relevant phenomena. Glaze formation. A further phenomenon that has undergone investigation in relation to high temperature wear prevention and lubrication is that of a compacted oxide layer glaze formation. This is the generation of a compacted oxide layer which sinters together to form a crystalline glaze, generally at high temperatures, from metallic surfaces sliding against each other. Due to the elimination of metallic contact and adhesion by the generation of oxide, friction and wear is reduced. Effectively, such a surface is self-lubricating. As the glaze is already an oxide, it can survive to very high temperatures in air or oxidizing environments. However, it is disadvantaged by it being necessary for the base metal having to undergo some wear first to generate sufficient oxide debris.